So the better way to make overloaded functions that are basically identical to each other except they have different types is to use what are called templates. So templates are a way to specify a pattern to say, okay, this is how I want my function to work, but every time that I would write long, just use a given type. And so that I don't have to copy and paste the same function 10 times and only make small changes to the types of those functions. Instead, I write my function once using templates so that it can be expanded to handle whatever types I may need it to do so. It's probably easier to walk through an example of this. Okay, so we've been looking at the swap function quite a bit. And this way swap generally works is you say swap some type, specifically a reference to that type named first and a reference to that same type named second. We make a new version of that type. We set temp equal to whatever the first value is. We set first equal to second. We set second equal to temp. Alright, that's how swap has worked in the past. Now, one thing we could do is by using templates, and the syntax for templates is you say template, and then with angle brackets you say type name, and then some identifier. And what this identifier will be replaced with, it'll be replaced with a specific type, like long. So every time we see template type here, you can just, in your head, turn that into longs, and now you have the version of swap that works with longs. Or you can replace it with double, and now you have the version of swap that works with double. So this is one way to write swap once, but to say, hey, I want my swap function to be able to handle arbitrary types. This swap can be used on ints, it can be used on longs, it can be used on strings, it can be used on types that you never even considered using swap on right now, but because you made it using templates, as long as this pattern works of making a new variable, setting that variable equal to the value of first, and then doing the actual swap thing, it will work just fine. So down here is an example of me using swap, and now note, I'm using swap here, and I'm using it with here I1 and I2 are integers. I can also use swap with doubles. Now, the only thing to note is that you generally want to use swap with the same type here. So if once again, swap assumes that this type here and this type here are going to have the same type. They must have the same type. They must match each other because they both have whatever the type that this swap was created to handle. And so the problem is that if you call swap here with two different types when swap expects to get the same type, unfortunately, the compiler is going to have to do some sort of conversion. The other thing to note is that you can actually force what the type of the swap function should be. So if you put in square brackets a long here, you're actually forced the swap to assume that it's working with a reference to a long and a reference to a long. And in this case, because I1 and I2 are ints, it'll actually force conversions to happen here as well. So generally, you shouldn't need to specify the type of templated functions because it'll just figure it out from looking at the types of its arguments. There are sometimes when you might want to be explicit about the types. And once again, the issue here is when you call a templated function that expects two different parameters to have the same type, if you don't give them the same type, then the compiler will get upset, or even worse, it might do some sort of conversion, like for instance, converting this int to be a double, or converting this double to be an int. You don't want to let the compiler be making those calls. You want to be doing whatever static casting you need to do in order to make sure that your arguments match very nicely with the expected parameters for a function. So once again, the point of a template is to solve a problem. What is that problem? The problem is you sometimes write a function, but you want that function to handle arbitrary types. Swap has nothing in particular to do with long, so why would you make a version of swap that just works on longs? Why not make a version of swap that works for any type? And so the template is a pattern that can be used to create a function as necessary. So when you're compiling your code and you're using a templated function, the compiler will actually look and say, hey, you're trying to use swap with two ints. Great, swap is a templated function. I'll make a version of swap that handles ints for you. And so once again, the templated function is not actually a function. It's really a recipe. It's really a pattern for how to make functions that have particular type signatures. And the reason why we're talking about templates right here is that templates are incredibly important in C++, and especially in the standard template library. This is why that T in the standard template library is there, is because most of the algorithms and data types that are in the standard template library are templated. They can handle arbitrary types. For instance, we're going to be talking later on about vector, which is a type that holds a list of things. Now, you can make a vector of ints, you can make a vector of doubles, you can even make a vector of ints if you want. And you write types and you write functions so that they can handle arbitrary types. So you don't have to have a specific function that works on longs. You write a template so that it could work on longs, or it could work on floats, or it could work on other types. So how do templates actually work? Well, the way that they work is, once again, you have a templated function here that is a pattern. It's a pattern for how you could create a swap function that has specific types. So once again, you say template, square brackets, type name, and then this my type here will be replaced with a specific type, like a long or a double or a pointer to a long or something. And then you write your function using this, arbitrary type. And so then when you call that function, the compiler will go, oh, you're calling swap with 2 integers. Okay, that must mean you're trying to use swap, the int version of the swap. And so it will create a version of swap that uses integers as your my type. And then it will call this function. It will call the version of the function that it made specifically for this function call. And so by writing a function as a template, these are what are called generic functions. These are functions that aren't specific, they're generic. They are able to work on a bunch of different types. So remember, a template is a pattern to make a function. It's not a function in and of itself. You have to instantiate it. You have to actually use a function call to tell the compiler, I want this template to be made so that I have a specific function that handles a specific type. Now, you can force the type of a generic function, of a templated function, by using the square brackets. You can say, actually, I don't care what the types of my parameters or the types of my arguments are. I want you to use a version of this function that is expecting longs, and I want you to cast my arguments into those longs, regardless of what their original type is. Generally, this is a bad idea because you generally don't want the compiler to be casting your types for you. If you want the version of swap that works on longs, make sure that your arguments are longs. And the syntax for forcing the templated type is to say the name of your generic function, and then in angle brackets, you say the type that you want that generic function to have. When you write the function, the my type, you want my type to be replaced with double when you instantiate it. The other thing to note is that you can sometimes not know what you want the return type for a function to be. And in templates, this is especially often the case where the return type of the function, you might not be clear what it should be. And so what you can do is you can actually use auto as the return type for a function. And the templated function will actually infer what the appropriate return type is by looking at what you actually return from the function. So if you're returning, an int, the auto will become an int.